this particular lesson is going to be like translating foreign languages. Only one language is English, and we're going to translate English into algebra. So we're going to use letters and so forth, but they're not necessarily going to be words. And the thing that I always like to tell my classes is this. When you read the sentence, you have to decide what depends on something else. Or a better way maybe to ask that question is, what do I need to know first before I can unravel everything else in the question? And let me just try this first sentence and see how it goes. It says the larger of two numbers is twice the smaller, and maybe we should have a number on the end right there. That's twice the smaller number. Okay, which number depends on the other one? Does the larger one depend on the small, or the small one on the large? Depends on the small. If you just tell me what that small one was, I know the large one, right? So that's the kind of question you need to ask yourself. You know, what do I want them to tell me first, and then, boy, I can answer everything after that. And the way we deal with that is we choose a letter, and I like to choose letters instead of using X all the time. It gets so boring. I like to use letters that represent what it is we're looking for. In this particular case, we're looking for numbers, and we'd really like to know what the small one is, so we'd say n is the smaller number. Okay, so in place of this smaller number here, we've translated that to n. So now let's read the sentence. The larger of two numbers is twice n. Actually, the smaller, the whole word is n, not just smaller. So let's read that again. The larger of two numbers is twice, I'll translate that, n. How do I write twice n mathematically? 2 times n, exactly. So I can come back here and write 2n, which means 2 times n, is the larger number. Now, unfortunately, they didn't tell us anything else about these numbers, so we can't find exactly what they are, but we have represented each of them algebraically. Let's look at the next sentence and see if we can answer the question, what would I like to know? And then I can tell you everything else. What do you think of this? The price of a book is $3 less than twice the price of the tape. If we knew the tape, we'd be in business, wouldn't we? Okay, so let's choose T. And again, the fact that I wrote T down is not carved in stone. If you'd like to use a different letter, go ahead. I just picked T. It's a little more interesting than accent corresponds to tape. So T is, it's not the tape, but it's the price of the tape. All right, so now we can come over here and start translating. The price of the tape becomes T. So now let's read our sentence. The price of a book is $3 less than twice T. Okay, so we got some things to deal with. How do I deal with twice T? 2t, just like we did above, 2n, this would be 2t. So twice t, that whole works becomes 2t. Now here's, this part is a little tricky. $3 less than 2t. How am I going to deal with that? Do I take the $3 and subtract 2t? Or do I take the 2t and take away $3? What's your best guess on that? Sure, because it's $3 below the cost of 2t. Exactly. So, I think we're ready to write down the cost of the book. It's 2t, take away 3 is price of book. And again, they didn't give us any more information, so we can't find out exactly what the book in the case will cost, what their prices are. But at least we have an algebraic statement that tells us what those prices are. Now, let's just push the envelope here a little bit and just see what happens. Suppose they said we spent a total of $8 for the tube. When we took the tape and the book up to the checkout, it cost $8. How could I symbolize that or write that algebraically?
You give a symbol to the price.
We have that right here. Oh, okay.
How you just say it.
The price of the book.
Oh, you have to add in another, the T, because we're buying the book and the T, right?
Exactly.
Yeah,
So we take the price of the book
plus the T.
plus the price of the tape, and the total is $8. Wonderful. You see, we just pushed the envelope on that a little bit. I'm just preparing you for something in the future here a little bit. Nice job. Nice job. Now, this one is really tough. We're going to have our thinking caps on here. I'm going to read the first sentence here. There's actually two sentences in the statement. The first side of the triangle is 3 times as long as the second side. The first side is 3 times as long as the second side. Now, if I just take that piece of the sentence, what would you like me to tell you? The length of which? The second side. Okay? I'm just going to underline that for a moment here. We're going to just hold that on the back burner for a moment. Okay? But if I tell you the second, you can find what? The first. Exactly. Very good. Very good. Now it says the third side is 5 centimeters shorter than the first side. So the third side depends on the first side. And the first side depended on the second side. So let's see if we can tear this down. I give you the second, you can tell me the first. Now that you have the first, you can tell me the wonderful. Now all we need to do is start picking some letters and writing some relationships. Let's use S. This is not a real good variable, but I'll be careful with my S because it won't look like a lot. S is the second side, the length of it. Okay, then how long is the first side? Wonderful. 3F is length. I'm going to abbreviate this first side. Now we said if we knew the first side, and we decided the first side should be 3S. So if we were to draw a triangle here, and I I don't know if that's exactly what it looks like or not. This might be S, and this might be 3S, and then the last side is 3S equals 5. I want to push the envelope one more second here. Suppose we went on further to say the perimeter of this triangle is 16. What sentence could I write algebraically? Perimeter is 16.
You have to add all three sides and equal 60.
Exactly. S plus 3S plus 3S minus 5. Notice how I grouped those when I set them? So we got each of them. And did I say 16? I forgot it. 16. Wonderful. So what we've been able to do here in at least 3 sentences is change the English language into algebra. And then eventually, as I showed you here, we can get to equations, and then we can start finding out what the value of S or T or N or S is. That's our next step. Now, there are some key words to look for here, and I'd like to look at a few of those. When you run across the word and if you're going to interpret that mathematically, what operation would that be, would you think? Say and. There you go, wonderful. That's addition. If you say increase, I'm just going to throw out a bunch of words here. Addition again. Twice. Multiply, or 2 times, if you would. Less than. Subtract, very good. Decrease. Subtract again. How about the word is? There you go. Very good. Very good. So there's all sorts of words, and I haven't hit all of them here, obviously, but I'm just giving you an idea of some of the words that you're going to come across here that just kind of automatically transfer into a mathematical operation here or relation over there.
Okay.